I feel like I'm living on the edge right now. Okay, so thank you for having me here. My name is Santosh. I belong to Orlando, so 407. Yeah, represent 407. I'm the Director of Technology at Spectrum Bridge. So that's my daytime job. What do I do with my daytime job? We do some very cool stuff. We provide broadband connectivity to developing countries. So it's something I really love to do. I wake up in the morning and love my job. So I'm fortunate enough to have that. I do some consulting work on science for standalone technology. And of course, I both help organize the Orlando user group and Orlando Codecamp. So if you guys ever get the opportunity, feel free to pop over to one of our meetups. Definitely make it for Codecamp because it's huge. It's got like 600 attendees every year, about 75 sessions. So there's a lot in there for everyone to like. I'm a frequent speaker at Codecamps, user groups, and also spoke at UNITE back in 2013. I don't know how I got that invite, but it was an awesome opportunity. So today I wanted to talk about Azure DocumentDB. Has anyone ever used Azure DocumentDB over here? Okay. So we have two. So the talk will not be focused on you guys. It's going to be for those who have not used it. Has anyone in here used NoSQL? Any kind of NoSQL? What?
Mongo.
Mongo, okay. This is very similar to Mongo actually. You can actually take some of your Mongo skills and translate them over to DocumentDB, which makes it really awesome. So for the rest of you, you're fairly new to NoSQL and definitely new to DocumentDB. So this is the perfect talk for you because what I try to do with my talks is I'm not trying to sell DocumentDB. I don't get paid for any of this. So I am trying to introduce, I started using DocumentDB in a full capacity about a year back. It's only been out in general availability for 1 year. So I think it came out sometime in 2015 with the general availability by Azure. So it's been out for 1 year, so it's a fairly new technology. I started getting into NoSQL and DocumentDB came naturally to me because I'm a .NET developer and I'm an SQL Server. So I wanted to take those learning experiences and translate them onto here. So before we dive into DocumentDB, so this is how I wanted to do it. I want to talk about NoSQL. I'd like to sort of do a primer on NoSQL and some of the basics. And then we'll dive into some different types of NoSQLs NoSQL data stores that are available out there. And then we will figure out what some use cases are for DocumentDB, when you should use it and when you should not use it. So I gave this talk at Codecamp, and one gentleman up front was trying to argue with me that he was exporting Mongo, and nothing I had said had convinced him to switch to DocumentDB. So I actually think that that's great because I'm not trying to switch anyone over. You have to use DocumentDB in certain scenarios and not use it in certain scenarios, which is what I'm trying to stress. So with that, I will get started on NoSQL. It's basically a marketing, it's something made up by marketing people, but there's nothing called NoSQL. Maybe they should probably name it something different. I've heard the term not only SQL used in relation to NoSQL. Basically, what the selling point of NoSQL is that you have large amounts of data. You can develop quick, and you can operate at a massive scale. That's the whole selling point of NoSQL. So one of the things that NoSQL does is it takes data and spreads it across multiple nodes. Now, why does it do that? So if at any point you feel lost or you have any questions, feel free to stop me. I think I have to.
All right, I'll look. I just look. I just didn't see it.
So this is kind of it's a database. It's got a user. The user has skills. Can you guys see this in the back? Alright. And they have some kind of experience at certain roles. So what we're trying to do is we want to store this in a relational database, right? So to store this in a relational database, we sort of store it in a users table. We have a skills table, and then we have a user experience roles table. Now to read this data, you are reading 6 different rows from 3 different tables for one record. So this is one record, right? This is one user who has a certain skill set and a certain level of experience. And to read that, you are reading 6 rows from 3 different tables. So the whole concept. So we all are, most of us started with relational databases and we're quite used to this. This is quite novel for us. But what happened was that in the middle of last decade, or in the beginning part of last decade, as people started to collect more and more data, and they hit something called web scale, which means massive amounts of data, terabytes, petabytes of data, and reading 6 rows from 3 tables for one record is efficient at this scale. But when you go to a scale of terabytes and petabytes of data, which is billions and billions of records, it turned out that it was quite inefficient. So here's the technique I use. Whenever I have, or I used to use, right? So I had a SQL Server database, and I needed to access records in a certain way, like only a few columns and a few tables. So I used to create these things called views in SQL Server. So you must be familiar with views. Everyone has used it at some point or another. So think of NoSQL as views, in that you take the data that you want and you store it in a denormalized format, which is what a view is. So, and the difference being that in a view, it still hits the table and does the query. This thing is stored in a flat format. So, this condition where you in order to build one record, you access records from multiple tables and combine them together. It's called impedance mismatching. And what we do in SQL Server is we often use like ORMs to overcome impedance mismatching, but that is at a large scale it is quite inefficient. So NoSQL is basically if you want to run the data at scale, and it has its own good and bad points. A very good example of a NoSQL database would be any kind of product store. So let's say you have Amazon, right? And with Amazon, when they insert a product, let's say they insert a TV into their database, this record has to be viewable by millions and millions of people, probably at the same time, especially if you're hitting it on Black Friday or something. So, pulling it from a database at that point in time is, by combining rows from different tables, is quite inefficient. And they tend to use NoSQL. I think they use DocumentDb much. Some of the positives of NoSQL are still talking about scale. NoSQL is basically what you do is you take all the data and spread it across multiple nodes. And the difference being that in relational databases, let's say you have a SQL Server database and you get a large amount of requests, you still have a single machine handling these requests. single point of failure. Now, of course, you can alleviate that to an extent by using some kind of sharding techniques, but it's still extremely complex to do that. With NoSQL, this kind of complexity is handled out of the box by the engine. So what you do is, instead of having a single machine handle loads, you spread it across multiple machines, and at that point it really doesn't matter because if you have millions of people in the database at the same time, the load gets spread across multiple machines. Am I making sense so far? So what I want to stress is that you have the regular RDBMS and you have NoSQL, and they both have their goods and bads. And really, I'm trying to stress what scenario you can use each one. It's not a SQL versus NoSQL. Yes.
I was just curious, is the data being stored among multiple nodes, or is it that the application is on it and the data is in one central place?
The data is being stored in multiple nodes.
So it's actually replicating the data. Yeah.
Yes. So that brings me to the next one, which is called. Okay, so a couple of points before I get to that. You have something called CAP theorem, which whenever you deal with a NoSQL database, it's CAP. It stands for consistency, availability, and partition tolerance. So this is a basic tenet of NoSQL. Now, whenever you design a NoSQL database, you have to choose. There's a golden triangle. There's consistency, availability, and partition. And because NoSQL databases are so spread out, you have to often pick between two of them. So that's the whole. If you take something out of this, hopefully it's CAP theorem. It's that when you're using a NoSQL database, you will often be forced to pick between these. And when we get to the Azure DocumentDB, I'll show you exactly how that works. So a couple of things about CAP theorem. Consistency basically means that, okay, so you have data being written to thousands of nodes, right? So if I write data to the database, let's say I write it to the database, and then I try to read it, I should get the latest copy of the data. So if I update variable x, if it was 20, and then updated it to 21, and I do a read, it should give me 21. To me, that is a consistent database. Now, why would we not want a database consistent? Or because I want the data, when I try to write to thousands of nodes at the same time, it could take a while to finish writing. So that impacts performance. So one of the things that trade off is consistency. So Azure DocumentDB actually has an excellent workaround for the whole problem with consistency. Okay, so a non-consistent database. So again, this is one of the hardest problems I had understanding NoSQL was consistency. I was like, why the heck would I not want to read the data as soon as I write it? But I looked into that, and so one of the things that stood out to me is how Amazon is. Because I always bring up Amazon because they're one of the bigger tech companies, and they obviously use some of these technologies. So whenever Amazon pushes out a product to the store, it does not automatically appear for everyone. It's pushed out to the database, and it gradually starts replicating across the world. So some people may see the most recent data, some people may see the old data. So, and the reason they do this is, again, because in most cases, they don't really care if it takes a while for the data to be updated, but they want to make sure that the performance is super fast and it matches these pages. So that's consistency. Questions so far? Availability is that basically if I query the database, it should return something regardless of what node it is. That is availability. And partition tolerance is is, it's one of the, it comes from distributed networks. Whenever you have distributed networks, you have latency, and you have, you can never control any the network condition. So that is what partition is. So what happens when the connection between two nodes breaks? That is the whole kind of partition element. So if I have a database with multiple nodes and the connection is broken, what happens when I query that? Should I return an error or should I return inconsistent data? So that's the kind of questions that you have to ask around this. Questions so far? I just want to make sure that this part is clear to everyone. So these are some of the examples. So the consistent, often you get consistent, because you have to pick between these two. This is where your relational databases lie. They are available and consistent. ACID properties. If you dealt with relational databases, you know what ACID is. Anyone what ACID? What's ACID? Atomicity, consistency, isolation, and durability. It's one of the basic, I guess, tenets of RDBMS databases. So your relational databases are right here, and your relational databases cannot be not partition tolerant. So that is one of the biggest problems you have with relational databases. And these are some of the other examples. If you want to have a better reading, I have included more reading material right at the bottom. Actually, if you look for my tweet, I tweeted out while I was talking. I tweeted out the link to the slides and the code for this topic. So you should have everything. So again, SQL versus NoSQL. SQL is, it's not that I should use SQL or I should use a NoSQL data store. Again, they can be complements of each other, not replacements. And what most systems are going, the way most systems are going these days is using polyglot persistence, which means they use a mixture of SQL and NoSQL. I use plenty of those. For instance, for a very good usage of SQL databases is storing users and roles and various data related to that. So I have databases that are 20 deep in relations, and those are SQL, regular RDBMS SQL server databases. For NoSQL, I use it for things that don't have complex relationships like log files. So that would be a very good example of what you use for NoSQL. And you can sort of take some load off of the SQL database to actually put in your log files. So if that's one way you want to start using DocumentDB, start with log files. They're relatively low impact. If you mess up the application that's accessing the log files, no one's going to complain. But more likely they'll complain if you mess up the actual login system. NoSQL on Azure. So if you wanted to use NoSQL on Azure, there's different technologies. So there's 4 different types of NoSQL available on Azure. DocumentDB, which basically stores in the DocumentDB, the data is stored as JSON, so that's easy enough to read. Anyone who's worked in web development is familiar with JSON, and the data is extremely readable, even better than XML. DocumentDB gives you a great, it actually gives you tools that you can write queries like you do on SQL Server database. You can actually select something from something where X is you write a regular query in document. That's another thing that attracted me to DocumentDB is you can translate a lot of your skills speed up and SQL Server into DocumentDB. So DocumentDB also gives the stored procedures, user-defined functions and triggers, which is again SQL Server. So that's really awesome. Think about it. Table storage, Azure table storage is more of a key value pair. Again, we'll probably not dive any kind of depth with these type of databases, but these are just for knowledge. You have HBase, which is the Hadoop type column family store, and you have Redis, which is used for caching. Again, it's a key value pair. So, okay, so what do you do once you store, what are some of the technologies on Azure that work with NoSQL database? Again, these are information only beyond the scope of this particular talk. But just to be aware of this, you have Azure Search, which is a really cool tool. So you can basically, in Azure Search, you can hook up our DocumentDB, and it allows you to run queries and embed them in web pages pretty easy. So if you want to query your log files and put that on a web page, Azure Search is different. If Azure DocumentDB integrates with some of these other data stores, including Azure SQL database, you have to have some kind of connector to do that. Okay, so the next question is, when would you use DocumentDB? So here are some examples. So Azure DocumentDB is, now you use it for data that's not relationship heavy. So if you have a 20-day relationship, that's really not Azure DocumentDB. Don't try to store encrypted data on DocumentDB. It's really not for. I want to be careful about this. It's not that it's not secure, but you cannot encrypt your data on Azure DocumentDB. So yes, you can secure it with keys, but once you access it, it's just there. So you can do various kinds of encryption in SQL Server and other stores, which Azure DocumentDB does not offer out of the box. If you have not used an encrypted table in SQL Server, welcome to it, because I didn't even know that this existed until I was reading into Azure DocumentDB, which is when I learned what encrypting SQL Server is. Catalog data, these are more for like product catalogs like Amazon. You can use Azure DocumentDB to store event logs. Now the thing with Azure DocumentDB is it's schemaless, so you can literally throw any kind of data in there as long as it's JSON, and it will store it. And there's no need for schema. When you query it, it's simply depending on the object you're querying, it just responds. So that's the really cool part about Azure DocumentDB. You can build things really fast. You don't have to go sit in a object relational model type development environment and try to build using object relational, and every time you change the database, change the EDMX file. You don't have to go through that process. You can quickly code classes, store it into Azure DocumentDB. So that's one scenario to use it real fast is if you have a non-homogeneous store. So one of the ways I use Azure DocumentDB is my company runs a lot of devices. So you never know what type of device what gets plugged into the network. So each device could return a different type of data when you query them for usage. So I simply throw that into Azure DocumentDB, and then later I go and try to sort out what type of data it is. It's used for gaming. Again, IoT, that's kind of the scenario I was talking about. Internet of Things, you can take large bursts of data and store it into Azure DocumentDB. Azure DocumentDB stores data on SSDs. It's extremely fast performing, so you have low latency reads and writes. That makes it extremely efficient to especially store large amounts of data coming into the system. Okay, so I had an interesting discussion at Azure Codecamp that I was talking about earlier. Gentleman up front was from a MongoDB background and was an expert in MongoDB, and hoped that I would convince him to switch over to Azure DocumentDB. Now the difference between MongoDB versus Azure DocumentDB, they both are document databases, which means that they store data in JSON format. What they differ is Azure DocumentDB is a platform as a service that's provided by Azure. So all the storage, all the management of the infrastructure is taken care of by Microsoft. So to me that's pretty good because I am not an expert at managing those types of systems. So that's why I prefer Azure DocumentDB. There are people who have worked for years on MongoDB and know how to tweak things in MongoDB to make it work like they want it to. They should probably use MongoDB. But if you're starting out, I would, especially as a .NET person, I would recommend Azure DocumentDB because number one, Microsoft takes care of everything for you. So again, like I said, it's fast performance, high availability, scaling is pretty good. You can have it scale on demand. It has flexible data models and rich query capabilities. So again, why would you use DocumentDBs? Because you're a .NET developer and you're an SQL developer. This actually has some of the, they try to keep some of the structures the same, and as long as you know how to translate it, it reads really well for that. It's very friendly for CRUD databases. So what's CRUD? Anyone?
Create, read, update,
Delete CRUD. So you build a simple app that has insert, update lists and stuff like that. Yeah, Azure DocumentDB works really well for that. In fact, my sample code is based on the CRUD application. It's so easy that you'll want to go home and start coding in Azure DocumentDB. It's JSON data, which I really love because I can store it, I can take the data and store it, and then I can access it in different formats. I can access it from a mobile app, that's a JSON service. I can access it from JavaScript queries, so it's like using Ajax calls, so it makes it really easy to read and access. Again, it has support for stored procedures, user-defined function, and trigger. I don't know that I'll go into those in detail, but I'll introduce those to you guys today. So the other thing is, so again, the second point from last is what I wanted to stress on is it's a database as a service, so you don't have to deal with the configuration, provisioning, and uptime headaches. We can literally take some of Microsoft's service lifecycle agreement facilities and pass that as your own, saying that this is what database availability is, and they take care of that for you. This is my favorite part when not use Azure DocumentDB. So don't go and move your current application to Azure DocumentDB. It will probably not be a good fit unless it falls into certain categories. The first one I wanted to warn you about is Azure DocumentDB has no local development instance yet. So I do my development on Azure's platform. So they're coming out with a local development instance at the end of 2016. So it's coming soon. But right now, if you want to develop, you have to develop against Azure's instance in the cloud, which costs money. Like if your data has complex relationships, Azure DocumentDB is best for denormalized data. So if you have 20 tables, try not to do that. Maybe a couple of levels is fine. You can actually, if you have employee and department, when you write your queries, you can do employee.department.name go to the queries. So you can query like you would do a link, but it's not great for deep relationships. So again, 15, 20 deep relationships don't do it in Azure DocumentDB. Actually, you can do rigid schemas, but there's no harm in doing that. But Azure DocumentDB gives flexible schemas. You can literally throw any kind of data you want in there as long as it's JSON. If your data has complex transactions, it does support transactions. So let's say you want to update 2 or 3 objects and you want it to be in a transaction, right? Which means that if one of the operation fails, you want to roll back. It supports it in a certain capability in Azure DocumentDB, but it does not cross a certain boundary. So again, that's a little bit of a complex operation in Azure DocumentDB, so try to avoid transactions. This is one of the important points. Your data needs aggregation. So again, Azure DocumentDB is schemaless, which means that let's say you have a table called employee, and it has the columns first name, last name, and email address. You can store that. The next record that comes in may only have first name and last name. The next record that comes in will have first name and email address. So you can store all of that, and Azure DocumentDB will take it. But if you want to do aggregation, it's really bad because let's say you're doing some data context. Let's say I'm doing the sale price of an item. You cannot trust, since it's schemaless, you cannot trust that the item on which you're aggregating across multiple records is going to be that the column that you're aggregating is going to be there. So you may have 10 records, 5 of them may have the price field, 5 of them may not have the price field. So in that case, if you're doing an aggregation, it's going to just take 5 of them and do the aggregation. What does that mean for the rest of the records? So it's a very complex business decision that you're having to make. So generally, it's better to avoid aggregation type operations in Azure DocumentDB. So again, it's good for logs. So you can throw like a bunch of logging data on there, but if you're storing spreadsheets, probably not the right one. Encrypted stories, they don't encrypt it. So it gets stored behind keys and everything, but the data itself cannot be encrypted any further. So unless we do your own encryption, you welcome to do data offering encryption capabilities as of yet. So again, if you're working in the healthcare field and you're storing data that needs to be HIPAA compliant, that should probably not be Azure DocumentDB. You can store logs for your healthcare application, but don't store the sensitive data. I love my last second points always. Don't move on there, data stored Azure DocumentDB. And finally, it's Azure specific. Everything is hosted on Microsoft Azure. So if you don't like the technology locking, which some people don't, they will rather host it elsewhere. So in that case, avoid Azure DocumentDB. Great. So we good with this so far? Before I jump into actual, any questions?
They do parameterized queries, or can you do parameterized queries with DBs?
Yeah, you can do that. I will actually, that brings up a very good point. I will introduce you to a query playground, which you can jump in and write queries to your heart's content. So, remind me to show you the query playground. So this is what Azure DocumentDB hierarchy looks like. You have to create something called an account. That's just a logical entity. Now, and I have all this. I'll walk through this step by step, so you don't have to write anything down. But just wanted to point out a few things. So first, to get access to Azure DocumentDB on Microsoft Azure, you have to create a DocumentDB account. So that's kind of a logical entity, but it's also important because when you create an account, it gives you the keys and it gives you the keys and the URL to access the Azure DocumentDB database. And then you have something called a database. If you have ever used SQL Server, the SQL Server, you have a server instance. That is the same as the database. So it's a little complex, but really not. Server in SQL Server is the same as database in Azure DocumentDB. Some of the things that come under the database, users and permissions. Collection. Now collection is all, again, a server is a logical entity, it's not a physical entity. You get to the physical entities when it comes to collection. Collection is an actual data store, so it's the same as an SQL Server database, or similar to the SQL Server database. Under collections, you have data which is stored as document. Document can have attachments, these are optional. And also under the collection, you can write stored procedures. This is trigger sets. And then these are different functions. You can create all the accounts and databases you want. You won't get charged until you create a collection operation. Just need to keep it going. So, we're ready for some code. Give me a minute while I switch my Mac. Okay, so I had a minor problem with the display, so I'm trying to get set up on the Mac. Just give me a couple of minutes. By the way, I have the code link tweeted out, but if you ever want to forget or if you don't have Twitter, you can go to github.com/ONETUG. This is the official repository for Orlando Document User Group, and we have a whole bunch of neat code over there, but mine it should be under the May 2016 meetups. this on my Mac, which I don't plan to. I'm downloading the code from my previous meetup talk. While we're doing that, to quickly talk about how to get started with Azure DocumentDB. So you'll need a web browser, obviously. Go to portal.azure.com. You have to log into your Azure account. So this is the new Azure portal, or this is not the classic Azure portal. If you want to use DocumentDB, it's not available with the classic portal. Just keep that in mind if you happen to search that classic portal. So the way you get to Azure DocumentDB is new. Data and storage. And Azure DocumentDB. So it's a pay as you go. I'm going to call this C and DocumentDB. I guess able to read this? Okay. I'm going to create a single net resource. Now, anyone familiar with resource groups? Can you tell me what it's used for?
I'm vaguely familiar with them. It's geolocation and
Yeah. It's a logical entity, so I find it really useful for when I do docs, but you can also do that in a lot of dev instances or testing instances. You can build entire environments under a resource group, and when you delete that resource group, the whole thing goes away. So that
but
is
also the term is like physical location, right?
yes, yes. So that's the other thing it does. It will determine the geographical data segmentation. Get this to the dashboard, and we'll create a DocumentDB account, and that is a really quick operation. So before I click on it, it should be on and running. So this is my. Let me see if my code is ready to go. So what this is it's a simple ASP.NET MVC web application. What I'm trying to show is a simple CRUD type web ASP.NET web application. So I'm going to quickly create a Azure DocumentDB database, store objects in it, and then we'll run queries on it. So simple CRUD that operation is things I need for that are, as I pull this up, I'll look at my web config. So any application you want to work on, I guess that's part of the web config. Can you read this in the back?
Yes.
Alright, so I would need something called an endpoint and an authorization key. This is the endpoint is where Azure DocumentDB instance is located, and the authorization key is what DocumentDB gives me to access the database. And a couple of other things I have in here is I will create a database there. I'll call it same. I'll call it same to-do list. And I'll call this same item items. So we have the account, the database, and the collection. So these are the database and collection items. I've coded them into the database. So I will need an endpoint and authorization keys. And how I get that is once this Azure DocumentDB account has been created, I can go to the settings for the DocumentDB, and I look at the keys. And this is the endpoint. So I click to copy, and I paste it into the web config file. And then I get the primary key. I could also get a secondary key and it works for both. I don't even know why they have to do that. So the next, one of the things we talked about earlier was consistency. So the consistency was the concept of a NoSQL database where to increase performance, they relay writes across the nodes. So if you want a faster performing database, you make it less consistent, which means that eventually the data will be there on all the nodes, which is known as eventually consistent. But it's not going to be there as soon as you write it. Now, you can make a database return data as soon as you write it, but that comes at a performance cost in the database. So, where that comes, well, you can specify that for Azure DocumentDB is the default consistency of your account. So, Azure DocumentDB, I don't know if you can read it back there, but it has 4 different consistency levels. Now, most NoSQL stores generally have 2 consistency levels, the strong or eventual. Strong means as soon as you write the data, it's immediately available. Eventual means when you write the data, it takes a while to propagate across the nodes. The reads are faster, but the performance is much better. So what Microsoft did was they were not happy with just providing 2 levels of consistency. Since this is a hosted instance, they could go and afford to mess around and come up with their own consistency levels. So with Azure DocumentDB, you have 4 consistency levels. You have strong and eventual, which are of course out of the box, or they should be there on any data NoSQL store. They also have something called bounded stateless and a session. So the difference between bounded stateless and session is bounded stateless writes faster, it writes data faster to the nodes. Again, it comes with the consistency, it comes with the performance cost, but it's not as high as if you are doing a strong database, which means that you can actually write a current application and it will work pretty well on bounded stateless. The session is the interesting one. From my understanding, about 95% of accounts on Azure DocumentDB use the session consistency. So it's like, you have 4 different consistency levels, so each one should be 25. Not about 95% of them use session consistency. Session is the concept that if a session is interacting with, if you open a connection and you're interacting with the Azure DocumentDB, if you write the data, it's immediately available to your session. It's not available to the rest of the system. So you can read and write as fast as you want. It acts like a regular RDBMS database, but to the rest of the system, it still takes a while to propagate across the world. So think of it like updating a profile, right? So I log into my profile, any online profile, and I update it, and I can see those changes immediately. But anyone else searching for my profile, it's going to take a while. It's going to take a while for them to see it. So I can update real time all day, and then I save it, and then everyone else sees it after a while. So this is the most consistent, most widely used consistency level for Azure DocumentDB, and we'll use that for our database. Right, so I have a model. This web application has a model called item. It's pretty straightforward. I have an ID, which is everything is string. I made it easy, string. You have ID, name, description, and completed or not completed. So it's like a task list, you know. Name, description, complete, not complete. So it's a simple model, and I have a controller for that model. This controller is pretty straightforward too. It has an index column, which basically lists all the items in the database, and I will get to how it goes about doing that. It has a create, which basically takes a model and binds it to the controller, and this operation right here inserts the model, the item that's passed from the model into the database. Do I need to make it larger?
Yeah.
You have edit. Edit is the same as create, except it's an update function. It takes the model and simply passes it to the database for an update. And this is simply the loading the code to get an item from the database and load it into the view. Then I have a delete operation. So the delete operation simply gets the item from the database and this is where it loads it, gets the item from the database, and this is the actual delete code, and I will walk into this in a minute. This is the code for details. So it's pretty straightforward. All it's doing is it's taking an ID and passing it to the database, and we can use that for insert or delete. Right? That's all the code I have in the controller. There's nothing else. This is my major class. But before I use this class, I want to show a couple of things. For your code to talk to Azure DocumentDB, you need a couple of NuGet packages. Packages, it's you have to look really hard to find the Azure DocumentDB NuGet package because it's called DocumentDB. So that's all you need. That's all we need to add to this project, the DocumentDB NuGet package. I don't think I have the latest one, but they keep updating it, so usually I'm running out of sync with the latest one. And finally, this class right here, the repository, so obviously the design pattern. What I need is a database, a pointer to the database. So it reads my web config, and it reads the database setting from the web config. It reads the collection setting from the web config. And then it runs code to read a create database. So the cool part about this is you can actually query the Azure DocumentDB store and run a link query on it and see if your database exists or not. So how I usually instantiate the application is I can query, I pass the database ID in there, and I run a query against the Azure DocumentDB, and that will tell me if the database actually exists or not. If the database doesn't exist, it creates it, and then it returns the database as an object. Now, I forgot to mention the client. Client is simply a class that is used, that is instantiated using the endpoint and the authorization key that I copied when I created the database. So you guys remember that? I copied the keys and the endpoint. That's what I used to instantiate the client. And the client is what I use to run all the database operations. We good so far? Any questions? I have to apologize. So I'm connecting my remote desktop to my computer in office. So when I click, it takes a while for it to catch up. So that's why it's a little bit jerky. So I have a few calls in here. One is get all items. What this does is it basically queries my Azure DocumentDB collection. Oh, before that, so like I created the database, I can also create a collection. So in Azure, like with Azure DocumentDB, not only can you query the system to ask for data, but you can also query to ask for, same way you query for data, you can also query to ask to see the collection of the database segments. If not, you can create them. And all of those are simple, like one single method calls to do a document collection, create a document collection, drop a document collection, or create a database, drop a database. It's easy, but you also have to be careful because you don't want to end up dropping something. So get all items, it queries my database and gets a list of items, and these items these records are of type item, which is the model that I'm sending it into the database. So you'll notice that so far I have not done any kind of mapping of my models to actual tables in the database. There is no ORM EDMX file sitting anywhere, so just keep that in mind. I'm promising that by doing this, by creating a document query and saying that it's of this type, which is item, all the objects that will return are of type item. So we talked about read and query, create database. So this is where you get into the meat of it. So I have a model of type item. All I'm saying in here is by passing this to my client as a create document call. It will actually store that with no object relational mapping. So that is the create. This is the get for a single item. So simple, right? Nothing overly complicated so far. Correct me if I'm wrong. And this is an code for an update item. And finally code for delete item. So that's all the code I have so far. So let's run this. I'm already seeing an error message. Alright, so the error I'm getting says this project references NuGet packages and unless one is enable NuGet package restore. Lost my connection. Alright, so I'm trying. Can someone help me here? I'm trying to figure out enable NuGet package restore. What is that? Yeah, it is.
Seems like a restore to do.
Yeah. Sorry?
Try to do a rebuild that.
When I try to rebuild, it says enable NuGet package restore. Doing a restore.
In the quick launch up top, try NuGet restore on the right side. In the help box at the very top, quick launch. Yeah, just type NuGet restore in there and see if maybe it'll give you the, because they want you to change a property. No.
Alright, let me do it the hard way. I'm going to remove these and add 3 others. So I created the code on Visual Studio 2030 trying to, because I could not use the computer, I'm running it on Visual Studio 2015, so just awesome. So I'm trying an update on the NuGet package for Azure DocumentDb.
Doing it live.
Yes, there you go. I live on the edge. I don't know if that fixed it. The missing file is package Microsoft package.
Great.
because when it works very beautifully.
No. The only other thing I would try is uninstall this one, and then when you install, choose 1.7.1 as the version in the drop down. Because it's pretty determined to be on 1.7.1. I just have to move on, unfortunately. Can you run the code from the Codecamp instead? If you demoed this before, maybe use the code.
That's the one I downloaded. So I have a list. So I guess. two items I need the database name. So C and I'll call this items collection. So quick refresher. All I had in here was a database. No collections or nothing. So when I go in and run this, according to my code, it should create. All I had was my account and no database, no collections. So when I run this, the code promised to create a database, to promise to create a collection. So let's see what happens. See if anything exists on the collection. So this is and obviously return nothing. Now let's go back to my item. This is the list page. There's nothing on this page. So then I run the create code. Create code. All it does is it takes the model, which is item, and it inserts or creates a document with that thing. So I can use it. I'm going to put a breakpoint. I'm going to give it a name. That's not complete yet. I don't know if it works or not. So I'm going to hit the create. So it takes the model from the controller. Controller calls this create item. As you can see, this item right here. Item 1 recovered from disaster, it has no ID because so it should insert that into the database and get all items should be in the database. So don't take my word for it, let's go for the database.
Attaching the same topic like yours to the server as spread application on the same server. So I have both frameworks that are spread.
That is the item that gets stored into the database. As you can see, it has, can you read this? Alright, so it has the name of the item, the description, is complete as false, and there are some other, you can actually, this is kind of a direct link, it's a direct link to the document, so if you ever wanted to just link that record itself somewhere on the internet, you can pass the part of the query and it will directly access the document. The ID is something that it's a grid and it's automatically created and it doesn't have to deal with that. So the next thing I'm going to do is add a second item. And we will say mark it as complete. And it should store that in the database. When I run the second query, you can see that it's stored on the second record item 2 and it's marked as complete. I can also edit them and then automatically updates it to the database. So simple CRUD application, nothing to once you install, then you get back in. That's the toughest part of it actually. Once you have the DocumentDB repository coded right, you can actually tie it into your models. The neat part is now I can change the model if I want to, because that would require me going to changes the controller and everything else. But you can change the model and pass in the model, and it will store. If I add or remove a field, it will store that it won't complain about that. It's going to store the new records as needed. So you can change your schema as needed. And that's kind of the whole appeal behind NoSQL databases, particularly the DocumentDB is the flexibility of schema. A couple of other things I wanted to show. So this is on DocumentDB.com, and I have a entire. I have all of this in my slides. On DocumentDB.com, we have a sandbox that has many sample documents, and you can look at the sample documents right here. And you can actually run different types of queries. So you can run a simple select statement, the where class. You can add different types of filtering, and you can do order by top. The neat part is this is like I think 2016 operational things actually added geospatial data, which means that you can actually store geographical data into geographical data in here. We can run queries. For instance, this one actually pulls all the volcanoes within a certain radius of a certain point. It shows it on. So that's pretty neat. You can actually store geographical data. One more thing I wanted to show before I do this was we have something called a this is the cheat sheet for all the SQL. list of commands that you can actually run. This is kind of a cheat sheet. So this gives you a list of all the commands you can run on SQL Server if you want to do joins. You can actually create and store procedures and functions. That is, I have a code sample for that, and I will make sure that I include that in the code here. But what a stored procedure is for DocumentDB is it's simply JavaScript code that you run on the server. So you can create JavaScript code, upload it to the server. So this is an example of that. This is the code for regex, user-defined function. It's JavaScript code. You take JavaScript code, you upload it to the server, and you can call it in your SQL queries, and it automatically run a user-defined function in your SQL queries. So there's that, and there's all these sample queries and everything else for it that you can run on there. So I think I will stop before I run into more issues. Actually, I will do one more thing. It's not. Do you have time for a couple more points here? So this is a collection. So you can also create a collection from the web interface. Create a collection. We talked about availability and partitioning. Now, availability is completely taken care of by Microsoft, and they give you a SLA for that. However, when you create a collection, you have to. So the CAP theorem, you have consistency. We already dealt with the consistency of the account level. So everything under that account has a certain consistency. If you want different consistencies, you just create different accounts. Partitioning, that is dealt with at the collection level. So when you create a collection, you can create all these types. So this, by default, when you create something, it gets created as this collection. This type of collection. These are some pre-canned data types. Now, one of the things you want to stress on for when you create a NoSQL database is performance. And performance is usually defined as throughput, which means throughput in the number of input-output operations, right? So the way DocumentDB defines throughput is with something called resource unit. One resource unit is the equivalent of reading a document that's 1 kilobyte. So if you read a document that's 1 kilobyte in 1 second, that's 1 resource unit per second. So that's your performance level. Now, when you configure your collection, you have to define the throughput. So if you have like large amounts of data coming in, like you get like logs from millions of devices, you probably want to up the throughput. Now this does not look like a lot, like 2.5K resources. Come on, that sounds like nothing, right? But you have to keep in mind that one resource unit is 1 kilobyte, so it's 2.5K is the equivalent of 2.5 megabytes per second. So you start to get into some decent performance areas. So 2.5 megabytes per second, if you're getting that amount of data, that amount of data streaming, that's a pretty intensive application. Now, the green ones are pre-canned type. So if you know exactly what kind of performance you want, you can pick the green ones. And if you don't know, I would suggest going with the standard one. the blue one, because it's flexible and you can change the throughput and for levels between 400 resource units per second to 10,000 resource units per second. So that's 10 megabytes per second. So this is where you control the performance of your database. The other thing you can control is a bit of the partitioning. I would generally stay off of that until you get comfortable with the whole NoSQL and how Microsoft handles it. But if you want to do your own type of partitioning, you can create partition instances of it. Otherwise, everything is a single partition, and Microsoft handles all the store. So that's the best of scenario. If you are having some kind of query issues and you determine that it's because of Microsoft destroying it, so you can sort of go back and do your own partitioning on the data, and that requires a little bit of expertise on using this. The other thing you can see is as I have to have a minimum of 400 throughput, so that's about 24 bucks. On the grand scheme of things, it's not that much, but if you create something and you forget to delete it, you can charge. So just keep that in mind when you're doing that. Starting December, you'll get a local development instance, so you can build everything locally and simply deploy the application as they run on the same way on Azure. So that's something I wanted to point out before writing this talk. So those are some of the simple concepts of NoSQL and Azure DocumentDB. I apologize for the technical difficulties. I was running out of definition, so that's a challenge. But I think we got through it. So if you have any questions, I'll take them at this point. Wow, this was a really good job. Alright, well, I think John has my info on the meetup page, so you can contact me if you have any questions about Azure DocumentDB or anything in Azure in general. I also do other things in Azure, like Azure infrastructure, platform, data platform, and things like that. So feel free to contact me. I have tweeted out the links, so if you want to share it with others. Right.